Okay, this is the supplementary tutorial covering the creation of an 8-channel mixer in the Faust language for use with the Jacktrip hub server tutorial that we talked about previously. Let me go ahead and get those instructions back on the screen here. This is the instructions for the Jacktrip hub server mixer tutorial, where we just had all this stuff. We had QJack control, QJack trip, and the Faust mixer. Now we're going to focus on making the Faust mixer from source. And so the source we're going to use is right here. It's an 8-channel mixer. It's identical to the 8-channel mixer example that comes with the Faust distribution. And you can even find it in the Faust IDE, but it does not compile there because it uses component directives, which are functions that include the component from another file, and that doesn't work, and the Faust IDE does not support that. So I basically just collapse that into one file and put it into this aggregated file on my website where you can easily grab it. And what you do is we're going to copy paste that code and put it in the IDE. So let's go to the IDE. So here is the URL for the IDE. Open URL in a browser, and we should get the IDE. Here it is. And so we also want the source code that we are going to use. So I select that, right click, open URL in the text editor. And so here I will just simply select all, copy, and then go back to the, let's go ahead and let that happen. You can use the microphone. And so in the IDE here, it's got a little 2-line program by default. And so I'm going to just paste over that with the 8-channel mixer code. And maybe we should talk about that a little bit. It should actually compile it. Oh, it has a problem. There's some error here. Let's see what it says. Detail. I hit it twice. So on line 1, there's a problem. So it's probably an incomplete copy-paste. There's an extra I in here. And we don't need any of this metadata. Declaring is just adding to the metadata that goes in the C++ file that's generated. So we can start with the import. This imports the standard libraries for Faust. And here is the 8x2 mixer. So it's 8 input channels, 2 output channels, and it's a stereo panning of each channel to the stereo output. And so the gain is a vertical slider. It goes from, it's initialized to 0 dB, so everything's in dB for audio levels, preferably. And so the output of that in dB will be converted to linear. This is BA is the prefix for the basics library. In standard Faust, you get a basics.lib, and all of its functions have the prefix BA. And then that goes into a smoother in the signals.lib library. And so this is actually from the standard Faust examples, examples/dynamic/volume.dsp. And so in example/misc/mixer.dsp, it actually uses it from that directory, and that doesn't work in the IDE. So it's a vertical slider. This orders it. So if, among other sliders, it will be relatively ordered using that number. And so the range is from -70 dB to +4 dB in increments of 0.1 dB. And this only affects the number of digits in the display of the dB readout. And so then that is a function that is the slider, and then its output is a floating point value that's been converted to linear and smoothed. And so to apply it, we just multiply it. It's a gain. You multiply the signal by the gain. So this is vol is a function that is a multiplication by that gain. And then we also similarly have a pan function. So it's doing power law panning as opposed to linear panning. They're different. Okay, you can look up panning to see when you want which one. So here we have a muter. So at the very bottom we'll have a checkbox for muting, and checkbox puts out 0 or 1, and when it's 0, we're not muting. When it's 1, we are muting, and so 1 minus mute will give us a gain control, a gate it's often called. So the mute gets turned into a gate because you multiply by this, and that's how you mute, very simply, and that'll get applied to both left and right channels in a stereo case. So the VU meter is to show us the level of the channel strip in dB. And this attach primitive is necessary because it's not producing a signal that gets used, and the Faust compiler will optimize away any functions that aren't actually affecting the output unless they're protected by this attach primitive. And so that's needed for displays only. So bar graphs and VU meters have to attach to the signal path. Oh, that's interesting. There's a pop-up manual that will describe this. I didn't know that was there. That's great. And so it computes an empty envelope, and it displays the envelope in dB. So here's the envelope definition. And so the output of envelope is in dB, and that goes to the vertical bar graph, which is a display that will show chan I. So that first argument is a counter for the channel number, and that'll display here. And then its relative order in the layout is given by that numeral, and the unit is decibels, and that'll give us a nice dB units printout. And the range is minus 70 dB to plus 5 dB, which is a little more than the minus 70 to plus 4 that we had in the slider for the level of the signal. All right, so then we define a voice as channel 1, channel 2, channel whatever, and so its argument is the channel number in this voice definition. And then here is our mute function, which then is a multiplication by a gate, which goes into a horizontal group that is consisting of the volume control, which is another multiply by the level gain. And it feeds the level gain into the VU meter. I'm sorry, that's actually the signal. So that's the signal that's been either muted or not and volume scaled. And so then we send it to the VU meter, which is a separate display. But then the signal continues and goes to the panner, and that will have a stereo output, and that will go into the stereo final bus. And so then the stereo output is defined as 2 volume control. So we apply the volume twice on the left and right channel. This is for the overall volume level. And that goes to a vertical group that gives us a VU meter for the overall output level in stereo. And so here's the right channel. So there's a left channel, right channel, labeled by L and R. And so then here's our final process function. It's a horizontal group named mixer, and it goes into the parallel combination of 8 voices. You can change that to any number here. So this is an 8-channel mixer, but this is the only number you have to change to make it any number of channels. And so this is a built-in function in Faust that will generate a parallel bank of these blocks, whatever this function returns. And so you pass it the channel number and get a slice for the mixer. And then those 8 channels get mixed down to stereo. If this were instead a mono signal path, then they would just all be summed by this operator. This is the fan-in operator. But because it's going from 8 to 2, it will sum pairs. And you can see it right here in this diagram. So you have pairs of signals, and the left channel will go to the left channel of the stereo, the right channel will go to the right channel, and then it'll interleave. So since it's going to 2, it'll just take 1, and it'll take the first 2 to this next block, and then sum the next 2, sum the next 2. So that's an interleaving fan-in, interleaving summing fan-in. And the other case would be block summation, which you can get using other functions in Faust. So here are incoming 8 channels, and they each have their own strip, and then they get mixed down to stereo. And let's go look again at the actual app, which is this one. So here is channel 1, and so it's got the panner here. It's got the pan displayed. That's the numerical value of it. Here's the level slider, And you have a nice dB scale in this VU meter for the channel. That's because it's in unit dB. That was in the metadata for the title string for the slider. The slider also has a value display in dB. And then there's the mute checkbox. That'll just multiply it by 0. And so all these channels are identical, and then you get to the overall output. So you have an overall output level, and you have left and right levels. And in the previous tutorial on the mixer, you saw all those in operation. But now what we want to do is just compile this thing in the Faust IDE. So we've got the code there. This is the Faust IDE in a web browser. So we don't have to install Faust. We just have to run the IDE, open the IDE web page, and put the code in that we need. And we know it compiled because we're looking at the block diagram down here. So the export button is going to let us choose our architecture. So we're going to use the cloud server that we're already using. Let's give it a name that we like. I've been calling it Mixer 8. And we're not on the OWL platform. That's a special hardware platform. This is an analog devices platform, a Shark chip system. This is Linux, so a lot of people use this one. And when you're in Linux, you have a choice of all these various app formats. So this is also audio drivers. GTK is the GNOME toolkit, the Windows system that's very common in Linux systems. And 64 bits is the norm these days. If you choose the -MIDI option, you'll get MIDI controllable faders, so you can actually control your mixer from MIDI. And you can also control it from OSC. So your client, you can have a client machine controlling it. And you could also make a mixer for every client and have each client use OSC to control its own mixer. And so that would be an advanced case. So here's some other cases. So instead of GNOME, you can use the Qt, Windows System Toolkit for the GUI, and same other options. You can make a C-Sound plugin. You can make a disposable plugin. This is really, I would say DSSI is superseded by LV2. That's your sort of state-of-the-art standard Unix audio plugin format. You can also make a Jack standalone console app that would be Jack aware and just run out of a terminal. You can do a Jack GTK. And so that's actually the kind of thing we want, isn't it? Because, well, on Linux, we would be choosing one of these because we're doing a lot of Jack connection. Jack QT, 64 bits, OSC. That's the one I want. That's under Linux. So, but I'm on a Mac right now, and so let me go down to OS X. You got, a lot of other things. You can make Faust apps for a web browser. That's not very useful for a Jacktrip web server. There are a lot of destinations possible here, even Android and iOS for Faust applications. But this Faust application is going to run standalone on a desktop, and those cases are primarily Linux, OS X, which is now Mac OS, and Windows, and probably Windows 64 would be nowadays, right? So let's say we're on a Mac and choose OS X, and then we're going to need a Jack. We need some sort of Jack case, and this is actually not up to date because there should be a Jack-QT-MIDI and a -OSC. But right now I don't even need remote control. I'm just going to use the screen sharing to control it. So I'll just choose Jack-QT and that'll be fine. And so we say compile. We know that's going to work because we saw the block diagram. And when it's done, so it's using this server to compile it. So that's why we don't have to install Faust. And then we'll get a download button. And that'll bring a binary application down to our computer. And it's got a QR code if you want to open it with a QR scanner. So I clicked on download, and here it comes. So this is downloading to the server machine, which, see if I can get the downloads folder to pop up. Well, I guess I'll go to the terminal. It's always where I want to be anyway. I have a quick shortcut to that. LSLTH gives me the most recent files in any directory, and the most recent file is the binary directory. which is what must have been what it called it. So let's see that. And sure enough, we have our Mixer 8 DSP. We have our Mixer 8.app. And so I'm just going to say open Mixer 8.app. Usually I can type. I have to be sitting more normally. What? It's right here. Oh, it would be nice if I was shifted right in my, I don't watch my typing, and if I'm shifted, it's bad. Oh yeah, so this is the usual problem in the Mac world. It doesn't let you just open an app you downloaded from the internet, so I'm going to open the current directory. And yes, O is an alias for open. And in the current directory, I open everything that's there, and then I find the app, and I right-click on it, and open it with a right click, and now I get the option to open it. So it's a little bit of a runaround, and Mac users, you probably all know this. And so there it is, and it works, and I'm done. This is all I wanted to do for this tutorial. As a final note, I'll just refresh these instructions, principally where we got the code and where we found the IDE, the Faust IDE. And this is a summary of what we did.